discussed about IPv6 have completed. Before IPv6, IPv4 also have done. So in IPv4, all logics like how to convert from binary to decimal, total IPv4 range, and IPv4 classifications, and each class ranges, and each class octet format, and each class networks and hosts, right? And network ID, broadcast ID, usable IP address, subnet mask is all the logics we have seen in IPv4. In IPv6 also we started discussing about how to convert from binary to hexadecimal. Like IPv6 is quartet format, like how quartets are being assigned and how to represent IPv6 by using basic three rules, like omission of zeros, successive zero substituted with single zero, multiple fields of zeros with double colon, like this. In first 64 bits of IPv6 address is network portion. Like we can indicate like /64 subnet prefix length. Correct? So today we'll continue with one more example is class A, class B, and class C. So give me one IP address example from class A.
10
Yes,
dot
please.
2 dot 9.8.
10.2.9.8. Okay. So give me one example for class C IP address example.
72.
92
192,
and 70
168, 1.1. Okay. See, actually, what is the range of class A IP addresses?
0 to
0
127.
to 127. 0 is global ID, 127 is loopback ID. We cannot use those. So 1 to 126 networks. Correct? Class B. Class B,
128
128
to
to 191.
191
128 to 191. Class C, 192 to 223.
25.
See, Class A examples are 126 networks are available in Class A. So we can use example for 1 dot network also, 2 dot network also, 21 dot network also, 25, 26, 28, 29, 30. It's all Class A examples, right? 126 networks are available. But why, if I'm asking, give me one example from Class A, directly you people started with 10 to 10 dot something. Hmm? Even in Class C also, there are so many IP address examples are there. 193 is a Class A, 194 is a Class C, 195, 200, 20 is all the Class C. But why people will be using 192, 168? So in IPv4, there are two categories. One is private IP address and public IP address. So where we use public IP address, where we use private IP address, the name itself is telling is that private IPs are used in private networks. Public IPs are used in public networks. Then what is private network? Private network is within a LAN, within an organization, within an office. We have to use private IP address. Private network, which is internet, public domain, is public IP address. So private IPs are assigned by administrator. Public IP addresses are assigned by service provider. You can read these points. Public IP address used on the internet, which is public network, it should be unique over the internet. Assigned by service provider, need to purchase from internet service provider. Private IP addresses used within the organization, private network or LAN. It should be unique within the LAN organization, assigned by network admin and free. So there are, for every class, there is certain range of private IP and public IP. Class A range is what? 1 to 126 is a class A range. From 1 to 126 range, so some range of IPs are reserved for private, like IP addresses starting with 10 dot 10 dot 0 dot 0 dot 0 to 10 dot 255 dot 255 dot 255. This is class A private IP address range. Remaining all are public IP address from class A. Class B 172 dot 16 dot 0 dot 0 to 172 dot 31 dot 255 dot 255 is also private IP address range. Remaining all are public IP address from class B. Like in class C, IP address starting with 192.168.0.0 to 192.168.255.255 is a private IP address range. So these all are private IP address range. Other than private IPs are public IP addresses from ABC classes. These all a range of IPs are reserved for private IP. Okay. So what are the special IPv4 addresses are available? We have private IP addresses, private IPs, and public IP. Other than private IPs are public IP address. APIPA IP. APIPA means automatic private IP address. Loopback IP. And global ID is default IP. Global IP 0.0.0. Multicast address is 224 series. These all are IPv4 addresses and types. Private IP, public IP, APIPA, loopback, global, and ED, multicast. What about IPv6? Yes, even in IPv6 also we have same type of IP addresses like private IP address, public IP address, APIPA IP address, loopback, global ID, multicast. These all are in IPv6 also available, but the terminology is different. We don't call it as a private IP, public IP. Similar to private and public, in IPv6 we call global unicast, unique local, link local, like this. If we see IPv4, private IP, public IP, APIPA, multicast, loopback, and default. Same type of IPv6 addresses. In IPv6 we call unique local, which is similar to private IP address. So any IPv6 address starting with FC, any IPv6 address starting with FC, it is unique local actually. Like any IPv6 address starting with starting with 2 series is a global unicast. Any IPv6 starting with FE, link local, FF. So this is by seeing these numbers we need to remember actually. If any IPv6 address starting with FC, that is unique local, means similar to private IP. Any IPv6 starting with the 2 series, 2, then it is a global unicast, which is similar to public IP address. Clear? So finally, now we can identify by seeing IP address whether it is belongs to which class IP and what is the network ID, broadcast ID, subnet mask, and IP address is private IP or public IP. It is usable IP or not. Like all the logics we know very clearly right now. Agree? Can be IPv4, it can be IPv6. So successfully we have completed IPv4 and IPv6. Any doubts?
IPv6, what are those, for example, unique local FC00, what are those /7 or /3/10?
/7 indicates starting 7 bits are fixed, range of IP, unicast, unique local. /7 indicates first 7 bits are reserved bits actually. Like remember priority bits in IPv4, priority bits 0 for class A, 10 for class B, 110 for class C.
Yep. Yep.
Similarly, here /7 indicates 7 bits are reserved for unique local, 3 bits are reserved for global unicast, like that.
Okay, thank you.
Excuse me, sir.
Yes.
Yeah, can an organization, like if there are two different organizations, can one organization provide few set of IP addresses to the users and the other organization providing the same IPv4 addresses to the users? Can that happen, or is it like single?
Yes, that can happen, no problem. See, whatever IP address right now you're using for your computer, same IP address I can use for my computer also.
Because the public will be different.
Public will be different.
Okay, got it.
Exactly.
Thank
Yeah.
you.
So that is how we can survive with IPv4. Even we have billions users are available. Also, what happening is private IP address. So private IP address, it is unique within a LAN only, within a local only. 10.0.0.10 IP address is assigned for one computer. Same IP address can't be used in the LAN, but other LAN can be used.
Okay.
Yeah. But public IPs are unique.
In IPv4, we are doing a subnetting, right? In IPv6, like how do we still use
Why subnetting in IPv4?
for getting more networks?
To minimize the wastage of IP address, right?
Correct.
Then in IPv6, why we are minimizing the wastage? There are trillions IP addresses. So subnetting is not required in IPv6 actually. If you want to do, you can do it, but not really required for subnetting in IPv6. Yeah.
So the network interface card will change for IPv6, or is it like just a software that needs to be added?
We need to assign IPv6 address for NIC.
The
NIC.
interpretation will be the same, right? Like the protocol tag that we need to add, right, in the system.
No, how we are assigning IPv4 address, like ncpa.cpl. Right click on Ethernet, properties. You click on IPv4. Similarly, if you drop down a little bit, you can see IPv6 also.
Okay.
So select IPv6 and go to properties. Here you can assign IPv6 address. Like 201A:2CF:29. The next line is asking for subnet prefix length /64. Default will take 64 actually. It's okay. Like this, we can assign IPv6 also. Okay.
Yeah, thank you.
Right. All right. So what is our main important point we are discussing? Main topic is basic requirements to form a network. Agree? The main topic we started. Have completed discussing about NIC, media, networking devices. What are the networking devices we require?
Switches,
Switch,
Which router?
router,
wireless access
firewall.
point, router,
Points.
and firewall. Yeah. Number 4, logical address, which is can be IPv4, it can be IPv6. Point number 5, protocol, which is TCP/IP. So we completed NIC, media, networking devices, logical address with IPv4 and IPv6. We'll continue today with protocol. What is protocol? As we know, protocol means set of rules, correct? Actually, when networks are started, I'm talking about very initial days, like when computer world is started, there are some manufacturer companies, computer manufacturer companies are Apple companies are initial actually. So Apple company manufactured some devices, some computers called Apple computer. But point is how these devices can communicate each other. So from device 1, you want to share some documents, you want to send some data, you want to send some mail. So both should communicate, both should talk each other. So they require some protocol. They need some language actually. Because two devices want to talk each other, two devices want to communicate each other. So that we call protocol, that we call language. A computer manufacturer company, which is Apple company, had been developed one language actually. That language is Apple Talk. So Apple Talk protocol will work in only Apple devices. Using this Apple Talk protocol, using this Apple Talk language, Apple devices and Apple devices can communicate each other. Similarly, in another vendor, which is Novell company, Novell also developed manufactured computers. But how Novell devices can talk each other? A Novell company itself is developed one another language called IPX, Internet Protocol Exchange. So this IPX will work in only Novell devices. Using IPX protocol, they can talk each other, they can exchange the data packet and they can exchange the mails and entire communication is established. Likewise, Microsoft computers. Like earlier we have Microsoft computers also. So Microsoft computers, two Microsoft computers to communicate, Microsoft it brings a develop one language called NetBIOS. So using NetBIOS, communication is possible with Microsoft to Microsoft. Then what about Apple devices to Novell devices? Novell device to Microsoft devices? No, not possible actually. Different protocols. They don't understand each other. They're different languages, right? They don't understand actually. But what about nowadays? How we are communicating? Like any vendor can communicate with any vendor, right? So you may be using a Dell computer, and in Dell computer may be running with Windows 11 or Windows 10, but you are communicating with multiple millions of websites and internet which we don't know. Like other end, a destination device, is it a Dell company or is it a HP, is it a Samsung, or is a Linux server, is a Android, is a Windows and Windows flavor. Like we don't know what is the destination device, but still you are communicating. Agree? So means any device can communicate with any device. So further we required one universal language, one universal protocol. So which can work in all vendors. That protocol is transmission control protocol over internet protocol, generally we call it is TCP/IPs were developed. So because of TCP/IP, we are communicating nowadays actually. So every communication device, TCP/IP protocol must be enabled. You practically understand from one device to another device. First device is source, second device is destination. So source and destination devices can be in the same location or in a different location. It can be LAN, it can be WAN. How data communication is been possible? That is need to be understood practically. You practically understand, think about it. On your daily basis, you're chatting with your friends, right? You're exchanging some documents with your friends through WhatsApp or any other social media. Have you ever think about it? Like I'm typing my text messages to my friend, like I'm sharing my selfie video to my friend, like that data packet is living from your mobile phone and reaching to your destination, you're reaching to your friend mobile phone within a seconds. But how is happening in the back end? Like what are the components you must require? What are the things you must require to move the traffic from your mobile phone to destination mobile phone? Have you ever think about it, guys? No, generally no. So we have a good internet speed and we are good, we are enjoying our bandwidth, right? But as to become a network engineer, we must know about the how data uh, communication is happening, the backend process. So to understand the TCP/IP protocol, we need some standard actually, right? So that standardization on international organization, which is ISO, International Organization for Standardization, is developed one reference model, which is OSI. So in 1984, ISO developed OSI reference model. This OSI for understanding of TCP/IP. Okay, Open System Interconnect. OSI was developed by International Organization for Standardization and it introduced in 1984. It is a layered architecture, consists of 7 layers. Each layer defines set of functions which takes part in the data communication. So what OSI is telling is that your data communication happening in 7 different layers, then each layer has set of functions actually. Like the top one is application, presentation, session, transport, network, data link, and physical layer. In numbering wise, physical layer is layer 1, data link layer is layer 2, like this. And top 3 layers, which is application, presentation, session, top 3 layers we call user support layers or we can call software layers. And bottom 3 layers, which is network layer, data link layer, and physical layer, we call hardware layers or we call network support layers. Network support layers are hardware layers. The middle one, which is transport layer, is core layer of OSI. Heart of OSI is transport layer. It has a main mechanism. Transport layer has main mechanism actually. Okay. All of you following me?
Yes, yes.
Good. So top one is application layer. What is the responsibility of application layer?
Develop applications.
Okay. See, application layer responsibilities. Application layer is layer 7, right? Generally, why we use computers as a user? Why we use computers? to interact with services. Agree? Like web services. From computer, can you use the web services? Yes. Like World Wide Web, www.google.com, gmail.com. Like it's all are web services. So whenever you use web services, the backend protocol works is HTTP, Hypertext Transfer Protocol. And from the device, if you want to download the file or if you want to upload the file, like uploading means a file is moving from one source to another location. Like that can be happen the backend protocol called FTP, File Transfer Protocol. All mailing system is working with backend protocol is SMTP, Simple Mail Transfer Protocol. For remote login protocol is Telnet, DNS, DHCP. These all are services, right? Then as a user, how we can interact with the services. Example, this is my desktop. I didn't open anything right now. It's my desktop. Like now my requirement is I want to open zoomgroup.com page, Zoom website name. What is the first step I need to do?
Browser.
How to download Zoom application?
Open a browser, right?
We have to open a browser and search on www.zoomtechnology.com.
Yes. First step, what is the first step we need to do? Open a browser.
Open a browser.
Open a browser.
Okay. Question number 2. Again, same question. Is my desktop, I didn't open anything. From here, I want to open, I want to download a software from internet. What is the first step we need to do?
We have to open a browser and
Open
we
a
have to go
browser.
to a search bar.
Yeah. So same question again. So from my desktop, like I want to open a mail, like inbox mail. What is the first step we need to do?
Open a
Open a
browser.
browser.
Open a browser to interact with any services. It can be HTTP or it can be FTP, it can be SMTP, like any services. First, what we need to do? Open a browser. So through browser only we can interact with any services. Agree?
Yes, sir.
Yes.
Even from mobile phone also. Example, you want to order something and food online. What do you do? What is the first step?
Open a browser.
Open related application, right?
Yes.
Application is app is nothing but application. Okay, you want to text to your friend, text message, chatting with your friend. What is the first step you to do?
Open a
Open a
application.
application.
Related
Open app.
application.
App means application. Okay, you want to do some online shopping, e-commerce. What is the first step you do?
Open the shopping applications.
Application. So user can interact with any services through application only. Agree? So generally web browser. So this web browser is nothing but application. So what is the purpose of this application now? Like user, how exactly user is interacting with services through application. So application is a interface. App is interface. Interface for what? Interface between what?
User and server.
User and service.
User and services.
Services.
It can be food delivery services or online shopping services. It can be booking like flight booking tickets or any services. You want to download a file, upload a file. You want to download a software, like any services. It can be soft user services, application services, or network services. User can interact with any services through application. That application is the best example is web browser. So what you can say about application layer now? It is responsible for providing an interface. Simple. It is interface for the users to interact with services. Example, web browser. So for downloads and uploads, what is the protocol works in the backend? FTP. For web services, HTTP. For mails,
Telnet.
SMTP. For remote login, Telnet. So as a user, we can understand these names actually, FTP, SMTP, but how devices understand what is your request? Is the request is a remote login, or your request is a mail, or your request is a download? Like how device can understand it? These are the names, right? HTTP, FTP is the name. So device understand numbers. That numbers we call port number. Every service is identified by port number, which is reserved port numbers. HTTP port number 80, FTP port number 21, SMTP port number 25, Telnet 23, DNS 53, DHCP 67 and 68. So every service is identified by port numbers. Okay. So data flowing from application to next layer is what? Presentation layer. Presentation layer is responsibility of providing standard format. Presentation layer says layer 6. What is the responsibility of presentation layer? Presentation is responsibility of providing standard format. Like what are the original files you have? Original files. Means can you send a text files? Yes. Images? Yes. Audio? Video? These all are original files. So these original files are providing standard format. Like for text files, for all text files, what is the standard format? .txt. For images, .jpeg, .jpeg, right? Audio, MP3, video, MP4. So what happening in presentation layer? Converting original files to standard format. This process we call data encoding. So presentation layer responsibility is a encoding the data, converting original files to standard format. And when it reaches to destination, in destination TCP protocol will convert standard format to original file. We call it is decoding. So presentation layer responsibility is encoding and decoding. Not only encoding and decoding, presentation layer responsibility is one more is encryption. Encryption and decryption and compression and decompression. It's reducing the file size. Encryption, decryption, and compression, decompression. Okay. These are the roles of presentation layer. Okay. Yeah. Any doubts? All right. Encryption means converting normal text to ciphertext format. Encryption text. So it is responsible for defining standard format to data, like encoding, decoding, and few uh, formats: encryption, decryption, compression, decompression. Okay. So data flowing from application to presentation. Next is session layer. What are the rules of session layer? Session layer. This is user computer. Well, if you have a Gmail accounts, yes. Facebook accounts,
4.
yes. Net banking,
Yeah.
yes. Okay, as a user now from your computer, how you can access Gmail or Facebook or banking? Generally, you're all in mails, inbox, outmail, sent box is all mails will be stored in your computer or in Gmail server.
Gmail server.
In Gmail server, like even the Facebook also, your comments, your friends list, your all the chatting, everything will be stored in your computer or in Facebook server.
Facebook server.
Facebook server, same like your net banking, your bank transactions, your history, your payments, your slips and certificates, is all the things will be stored in your computer or in bank server. In bank server. So as a user now, how we can access Gmail, my inbox mail? Tell me what is the steps you need to do? I want to open my inbox. What is the first step?
Open the browser. Go to the
Opening the
email
browser means which layer will come in the picture?
application layer.
Application. Okay, after opening the browser, then you can type gmail.com. Once you type gmail.com, now Gmail will ask you about username and password.
Yes.
So we enter normal username and password, normal text format. That normal text is converted to ciphertext. Means which layer will come in the picture? Presentation layer, encryption.
Presentation layer.
Yeah. So once you entered on login, then one session is established from user computer to Gmail server. Interaction is started. Session
Yes.
established from user to Gmail server.
Okay.
And you are reading your mail and replying to the mail. So you send it and your work is done. In meanwhile, a session is been maintaining action. Session is maintained. Once your work is done, you log out. Session terminated. So three actions: establishing session, maintaining the session, terminating sessions. So these are common for any website. Even the banking also, in banking also, bank website also what we do, we type open a browser and type
Yes.
hdfc.com. You'll ask your username and password, and we enter normal username and password. It has been converted. Presentation layer. Once you log on, a session is established from your PC to bank server. So inside your bank, your website, how much time you're spending, like you are doing the transaction and history and certificates and payment, everything is done. Means your session is maintained. Once your work is done, we used to log out, then session is terminated. Is all the things is taken care about by session layer. The best example, every day in the morning by 7:55 a.m., what you used to do, guys? Or 8 o'clock, what do
Open,
people do?
Into
Open a browser.
open your browser
Means which layer will come in the picture?
application.
Application layer.
Application. Then we type www.webex.com. And it'll ask your meeting ID and meeting password. So we enter normal meeting ID and normal password, normal text format. It is converted to ciphertext. Means which layer is taking care about it?
Presentation.
Presentation layer. And once you click on the join meeting in the interaction, the session is established
Section.
between from your computer to Webex server. Now your session is under maintenance. Like once our session is done, then we hit the meeting. Once you end the meeting, the session is terminated actually. So if you visit any website, the three actions should be happen actually. Establishing a session, maintaining session, and terminating session. These are the taken care about by session layer. It is responsible for establishing, maintaining, and terminating sessions. Every session is identified by one ID called session ID, or we call interaction. Okay. Yes, please. Any doubts? Yeah. The data flowing from application to presentation, presentation to session, session to transport. So transport layer is a core layer of OSI. It is very important actually because it has a major functionalities. Application is only one responsibility, which is interface. Presentation layer only one responsibility, which is providing a formats actually. Session layer, sessions will take care about, but transport layer has major responsibilities. Or no, it provides data delivery mechanism between the application and the network. So major functions are identifying service, multiplexing and demultiplexing, segmentation, sequencing and reassembling, error correction and flow control. These are the responsibilities of transport layer. Point number one, identifying service. What is identifying service? So the services comes under, like majorly, all services majorly differentiate into two protocols, TCP and UDP. Like what are the services we have listed here? Like HTTP, FTP, SMTP, Telnet, DNS, DHCP like this. So some services works under TCP, some services works under UDP. Like HTTP, FTP, SMTP, Telnet, these all are TCP services. Like DNS, DHCP, TFTP, these all are UDP services. So what transport layer will do? User request. Your request is your request service is under TCP or UDP. It will check it out actually. Then what is the difference between TCP and UDP? Can read this point. A protocol which takes care of data transportation at the transport layer are TCP and UDP. Can anyone read once again about this point?
Protocols which takes care of data transportation at transport layer are TCP and UDP.
What is the meaning of it?
It is తెలుగులో చెప్పండి.
Yes, please.
It is responsible for the data transfer.
చెప్పండి.
It is responsible for data transfer.
Okay. Protocols which takes care of data transportation at transport layer are TCP and UDP. It means what is the purpose of TCP protocol? Data transportation. What is the purpose of UDP protocol?
Data transfer.
Data transportation. Both protocols. That is what protocols that. So which takes care of data transportation and transport is TCP and UDP. So both protocols for purpose is same. Then why two protocols? The protocol transportation behavior is different. So TCP data transportation behavior is different and UDP data transportation behavior is different. This is the difference between TCP and UDP. TCP means transmission control protocol. Like it's a connection oriented, supports acknowledgement, reliable communication, slow data transportation. And the TCP is identified by protocol number 6. Examples like which services comes under TCP is HTTP, FTP, SMTP. Like in UDP, user datagram protocol is connectionless, no support for acknowledgement, unreliable communication, faster. Protocol number 17, DNS, DHCP, TFTP, these all are examples. Clear?
If they use the UDP in ML, like, what kind of areas they use that UDP. We know the TCP is generally used for all the, transmission kind of anything like HTTP, FTP, or SMTP.
No, first we need to understand the difference between TCP and UDP.
Okay.
Difference is what here? Connection oriented. TCP is connection oriented. UDP is connectionless. What do you mean by connection oriented? Connection oriented means what?
It has a connection.
See here, this is scenario. Two devices, host A and host B. Host A want to send some data to host B. So host A is a source, right? Host B is a destination. Which protocol can take care about your data transportation? It can be TCP, it can be UDP. Example, TCP protocol. How TCP works is, in general phone, in telephone conversation, in normal your mobile phone telephone conversation, after dialing, once if you answer, once you lift your call, what is the first word we use?
No.
Hello. Why hello?
That was the
Unique
word
form.
used by the person who invented this form for the first time.
Okay. Okay, but what is the main purpose, man?
Knowledge that you
Greetings.
To interact with the person who is opposite side.
Interact. You want to inform something, information. Directly
Yes.
can inform now. Then why hello?
To know the presence of the person.
Presence of the person.
Presence of the person. So thing is, hello packets are used. Hello, that the hello is dummy packets actually. Nothing is there, right? We say simple hello. Other person also will say hello actually. Nothing is there. But the thing is that is for acknowledgement. By exchanging hellos, both person can make sure the line is very clear. No drop off, right? No droppings. So voice is, yeah, I can hear your hello very clearly. Then if we say hello, other person can clear hello clearly, then both person can confirm that our line is what? Clear. Then actual conversation is started, or actual communication started. Agree?
Yes.
Is it good thing or not?
Yeah, good thing.
Yeah, it is good conversation, but without hellos, directly if you're answering like, hello friend, how are you? Where are you? Come on here, join in. Continuously speaking out. It's unreliable communication. There is a chances to your voice drop. Correct? So similarly, TCP protocol also will do the same thing. Like how TCP works is, if any device want to send the data to destination, directly it won't be sent actually. What TCP is doing is, before sending your data, first it will send one packet called synchronized packet. So host A sends a TCP synchronized packet to host B. It is sending one SYN packet, we call SYN, synchronized. In shortcut, we call SYN. It will send SYN packet. So means host B, let us sync up with me. I want to share some data packet. Then host B will reply for that. Yes, I have received your synchronized packet, and I am also syncing with you. That is we call SYNAC, synchronize acknowledgement. And again, host A will send thanks for your acknowledgement. Will send an acknowledgement actually. So this process, these three packets is done. This process we call TCP three-way handshake process. So once TCP three-way handshake process done, then connection is established between source and destination. After connection established, then data is being transmitted. So TCP protocol every time will do this three-way handshake process. Once between the source and device connection is established, then only data is being sent out. Then there is no chances for data loss now. Is there any chance for data loss? No chance at all, because it is very clear. They are syncing up. They're connection oriented. Host A, host B, they're connection oriented. They support for acknowledgement. Connection is established, connection is clear. Then data is being transmitted. Then reliable communication. Communication is very reliable actually. No, there is no chance for data loss. So TCP protocol every time for any communication will use TCP three-way handshake process. In TCP three-way handshake process, what is the first packet? SYN means synchronized packet. Second packet, SYNAC, synchronized acknowledgement. Third packet is acknowledgement. Once TCP handshake process done, then connection is established. In case of UDP protocol, in UDP, no three-way handshake process. No acknowledgements. That is what it is a connectionless. It's showing here. Connectionless, no support for acknowledgement, unreliable. There is a chances for data loss in UDP protocol because no acknowledgement, no 3B handshake process. But fast data transportation. Why TCP is slow? Why UDP is faster?
In TCP, it waits for the acknowledgement and sync and all, but in UDP, it doesn't require all that. So I think it's fast.
Excellent. Correct. So because in TCP, there is a mechanism called three-way handshake process. It is sending synchronized packet, waiting for SYN acknowledgement, again acknowledgement, connection has to be established, then data is being sent out. There is some process actually. But in case of UDP protocol, no three-way handshake process. Directly it will send data packet, faster communication. So which is the best, TCP or UDP?
UDP.
Both protocols are best. TCP and UDP. But we should understand what scenarios, what cases we use TCP protocol and UDP protocol. And UDP is a faster communication. The best example is like a live streaming, video calls, live streaming. Like in live stream, what type of communication do you require? Faster communication or reliable communication?
Faster one.
Faster. So UDP services. But you are sending some mail, you are downloading some software. What type of communication required? You require a faster or reliable?
Faster.
Reliable.
No. If you are
Reliable.
downloading some files,
Reliable.
it should be reliable. Like complete software has to be
Not lose
downloaded.
any
Na?
data.
Yeah, otherwise you lose your data. Even at least one compatible file is missing, so the software is failed. It should be reliable. So where you will use faster communication, there we use UDP services. Wherever we need a reliable communication, we use TCP services. So in real time, we use both protocols, TCP and UDP. So this is taken care about by transport layer. So transport is going to identify service, whether the service comes under TCP or UDP. If it's a TCP, three-way handshake process. If it's a UDP, faster communication. So this is what exactly happening in which layer?
Transport.
Transport. Yeah. Multiplexing and demultiplexing. Multiple services are combining and sending through one channel actually. Like we do have a separate internet cable for HTTP service. Do you have a separate internet cable for FTP services? No, we have only one channel. So through this channel, like all services, multiple services, your FTP request is going, your SMTP request, your mail service, your telnet service, all services going through one channel. How it can be possible? Again, transport layer will take care about it. What transport layer will do? It will implement a multiplexing mechanism. Means it's combining multiple services and going through one channel. When it reaching to destination, I mean, when it reaches internet, again distribute HTTP request to HTTP server, FTP request to FTP server, distributing to respective servers. We call demuxing, or we can call demultiplexing actually. Clear? So identifying service, multiplexing and demultiplexing. Segmentation, dividing large amount of data into smaller packets. Because a NIC card maximum is 1500 bytes only. Each data packet maximum size is, we call MTU, maximum transmission unit size is 1500 bytes. If it is more than 1500 bytes, should be divided into smaller chunks, smaller packets that we call segmentation. And every segment there is a sequence number, that is sequencing. And based upon the sequence number, you can rearrange it for proper communication. We call this reassembling. Like if you have any, if any data packet has error, like if it is more than 1500 bytes, it will correct it by error correction, flow control. These all are the responsibilities of transport layer. Any doubts?
Sir, excuse me, sir. So TCP and UDP are set of rules. There is no hardware, sir. Everything is a software.
No hardware. This is application, this software. Yeah. Protocols. The TCP is UDP protocols, not a hardware. Yes. All right. So let us stop for here for today till transport layer. And bottom three layers, which is network and data link and physical layer, will continue on Monday. Thank you.
Yes, sir. Thank you.
Thank you.
Thanks, everyone. Monday I'll give the link for WhatsApp group. Okay.
Okay, okay.
Okay, sir.
Yeah.
Okay, sir. Sir, one more thing. When we'll get the material for this CCNA?
Web links. Once group is created, I'll share in the group.
Okay. Who are in local, they will get a book also.
For hard copy, we don't have a stock in office for hard copy.
Okay. When we could